projectiles. In projectile motion, the body moves in a vertical plane. It's just like in case of a stone being thrown, it moves both in the horizontal direction as well as in the vertical direction. So it's follow a parabolic path. So the body will be moving in a vertical plane, and the only force that acts on the body is gravity. So you call a body moving under gravity in a vertical plane as a projectile. Okay, a body moving under gravity in a vertical plane is called a projectile. Body moves both in the horizontal direction and the vertical direction simultaneously. At the same time, it moves in the vertical direction and in the horizontal direction. So we have two different kinds of movements which we have to combine to get the actual movement of the body. In case of a projectile, both horizontal and vertical, we need to combine them together. And of course, the only force that acts on the body is the gravitational force, which is acting downwards. And of course, we will not consider the air drag. We assume that there is no air drag, which is nearly true, because whenever we talk about projectiles, they are not moving too fast. There is a reason for that too. So the only significant force that acts on the body is the gravitational force. Now it's important that to consider the motion of a body in a vertical plane as projectile motion, its range should be far less than the radius of curvature of the earth. It means that we need to assume that the range is on a horizontal plane. It does not curve along the surface of earth. So only those cases where the range is comparatively small, we can consider the motion as projectile motion. So range is the maximum horizontal displacement. We call it range, and the percentage with the letter R. R must be very small compared to the radius of the earth. That's very important for projectile motion. R must be very small compared to the radius of earth. Now if we take that case, then it implies that we can consider that the body accelerates in the same direction at every single point on its trajectory. It is actually, you can see that in the picture, it is acting always downward, straight downward. You can see that every point it is accelerating in the same direction. The acceleration, vertical acceleration, is always parallel to each other at every single point. You can see that in the diagram. And the value is obviously equal to acceleration due to gravity. So this particular condition can only be applied provided we take the range very small. So that is an essential thing. So the maximum height is usually represented by h0, and of course the g would be acting in the same direction, downward. And if you take any other point, you can see that the g is always acting downward in same direction. This is very important in case of projectile motion. Now, if you split up the motion into horizontal and vertical components, we can see that the horizontal motion of the body is at a constant speed. Body moves at constant speed or constant velocity in the horizontal direction, because there is no acceleration, there is no force acting in the horizontal direction, so there is no acceleration to the body in the horizontal direction. So in the horizontal direction the body is moving at a constant velocity. But in case of vertical motion, the vertical component of the motion is uniformly accelerated motion, because the body has a vertical acceleration which is acting downward at every single point. At every single point, the body is accelerating downward at the same rate, which is equals to 9.81 the g. So, horizontal motion is uniform motion, vertical motion is uniformly accelerated motion. So, if you combine them together, you will get the net projectile motion of the body, how the path is formed. And of course, since we ignore the air drag, the parabolic trajectory of the projectile will be symmetrical about the peak height. If you take the peak height, the parabolic, it's parabolic, the path will be always parabolic, and that will be perfectly symmetric about the peak point, the midpoint. Now, we put all these ideas into the picture, and then we will try to work out all the different quantities involved in projectiles.